to factor out the GCF. So step 1 is to factor a GCF. Step 2 is to look at the number of terms. Okay, if you have 2 terms, we're going to look for a difference of squares. If you have 3 terms, we're going to factor with the x, with the big giant X. And if you have 4 terms, you're going to use grouping. Okay. So 5 and 45, x to the 5th and x. These both have a 5x in common. If I take 5x away from 5x to the 5th, the 5's cancel each other out. There were 5x's, I have 4 left. 45 divided by 5 is 9, and I took the x away. Even exponents of perfect squares, remember we said you just divide by 2. So that 5 hangs out. The square root of x to the 4th is x squared, because I divide by 2. And then the square root of 9 is 3. So I have x squared plus 3, x squared minus 3. And then I check again to make sure I don't have any more perfect squares. Because remember I showed you that extreme example yesterday where we could keep going. But 3 is not a perfect square, so I'm good, I'm done. Oh, thank you. Yeah, sorry. Yeah, the x didn't go away. It's hanging out. Okay, here I look, are there any GCFs? I do have a GCF. My GCF is 7. Yeah. Here, 45 divided by 5 is 9. Does that help? Okay. So whatever you pull out of the parentheses, you have to pull out of both, or if there's 3 things inside, you have to pull it out of everything, or else it's not valid anymore. So, because if I multiply it back in, I'll get that 45 back. So here I have 21 and 7, and they all have a 7 in common. Right? You guys agree? 7 and 21 all divide by 7. So I'm going to factor that 7 out. If I factor the 7 out here, I have an x to the 3rd. So 21 divided by 7 is 3, and I have an x squared. 7 divided by 7 is 1. 21 divided by 7 is 3. Sorry, there should be an x on that one. 1x and 3. Okay. Then I have 4 terms, so I'm using a grouping situation. I'm looking at the first 2 and then the second 2. This 7 that was there continues to hang out. From the x to the 3rd and x squared, I can take out 2 x's. You see that? And that leaves me with 1x and a 3. Because I took 2 x's away from each of these. And from negative 1x and negative 3x, I can take out a negative 1, and that leaves me with an x and a 3. I'm just going to do that for right now. So these match. So I have x plus 3 and x squared minus 1. And then I check again. X squared minus 1, perfect square, perfect square. So I'm not done yet. This is a difference of squares. So the 7 stays, the x plus 3 stays, and then this x squared minus 1 gets factored to x plus 1 and x minus 1. Okay. 6 and 96 will both divide by 6, I believe. I just need to double check. Somebody divide 96 by 6. 31. Thank you. No, not 31. 16. Okay, so they have 6 in common, so I can take the 6 out, and I'm left with x to the 4th minus 16. Perfect square, perfect square. So the square root of x to the 4th is x squared. The square root of 16 is 4. perfect square, perfect square. So I have to check that again, right? So this is done, the 6 is done, but this is not done because I have another difference of squares. So I carry down the things that I'm not working with. Square root of x squared is x, square root of 4 is 2, so I have plus 2 and minus 2. And then I'm done because nothing else can be factored. Okay. For G, 6, 30, 24, and 120 will all divide by 6. Do we agree? So I'm going to take that 6 out. And I'm left with x to the third plus 5 x squared minus 4x minus 20. Okay. I've got 4 terms, so I'm using grouping, so I split it in half. And I look at the first 2. This 6 is still hanging out, so it's just there. X to the third and 5x squared have 2 x's in common, so I'll take those away, which leaves me with 1x and a 5. Negative 4 and negative 20 have a negative 4 in common, so if I divide them both by negative 4, I get x and positive 5. Those match. So I take my x plus 5 out, and then I have x squared minus 4, which is a perfect square, difference of squares, sorry. So I have to factor it some more. Square root of x squared is x, the square root of 4 is 2, so I have plus 2 and minus 2. So you just keep looking in your parentheses until nothing can go any further down. Once you've got everything factored as far as it can go, then you can stop. Solving equations. Okay, the first step to solving equations is you have to set it equal to 0. Then the second step is you factor it completely. Well, we already factored this one just now, so I'm going to use that same example. So it's already set equal to 0. That's good. We have factored it completely. The next thing you do is you split it. And every parenthesis or factor gets set equal to 0. Now in this case I have a 6 out here, but if this had been a 6x, then I would say 6x equals 0. Does that make sense? Okay. So I have x plus squared plus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. This is going to give me x squared equals negative 4, and we are not in the imaginary number system, so this one doesn't work. Because you can't have a square give you a negative. There's no such thing as a perfect square that's a negative, right? So that one's done. That's out. I'm going to subtract 2 from both sides here, and I'm going to get x equals negative 2, and I'm going to add 2 to both sides here to get x equals positive 2. So in this particular case, x equals 2 or negative 2. We had an imaginary solution, but we're not in the imaginary number system, so we just ignore that for right now. Okay. The 6, we just, if you were to basically divide both sides by 6, it would cancel out, and 0 divided by 6 is still 0. So you can just ignore it if it's just a plain number. The difference would have been if it was 6x times, let's say like this, then I would say 6x equals 0, and x plus 2 equals 0, and x minus 2 equals 0. So if there's an x involved, or a y, or whatever letter, then you set it equal to 0. But if it's just a plain number, you can just, it goes away. You can just ignore it at that point. So let's do one more. Let me try. Let's do this one. All right, nothing in common from all of them, so I can't factor anything out. So I'm going to use grouping because there's 4 terms. These have 2 m's in common. So I'll get 2m plus m. And 50 and 25 have a 25 in common. So I'm going to do negative 25. And I get 2m. Sorry, 2m plus 1, not 2m plus m. Minus 25. Minus 25, and then 2m plus 1 equals 0. Okay, so I get 2m plus 1 times m squared minus 25. And this is a difference of squares again. Perfect square, perfect square. So I get m plus 5, m minus 5 equals 0. So I have to set all 3 of those equal to 0. So 2m plus 1 equals 0, m plus 5 equals 0, and m minus 5 equals 0. Right? 3, 3. Subtract 1, and I get 2m equals negative 1. Divide by 2. M is negative 1/2. Subtract 5. M is negative 5, and then add 5. M is positive 5. So my answers here are negative 1/2, 5, and negative 5.